Silicon Valley has a very specific obsession right now. They want to put artificial intelligence right in front of your eyeballs. The blueprint for wearable computing seems settled. You take a pair of glasses, cram a display into the lenses, hide some microphones and cameras in the frames, and project the internet directly onto your field of view. But in August 2026, a bizarre anomaly popped up in Apple's code. A developer digging through the release candidate for macOS Tahoe 26.7 stumbled across a hidden file titled Visual Intelligence Demo. The video tucked inside showed a user holding up a book, but they weren't wearing smart glasses. They were wearing a pair of AirPods equipped with cameras and asking Siri to scan the cover and save it for later. It's a jarring contrast to the rest of the industry. While everyone else is racing to build heavy goggles to overlay glowing text onto reality, Apple is quietly testing tiny cameras on a standard pair of earbuds. Why would the most successful hardware company ignore the industry's push for face-mounted screens just to bolt a lens onto an audio device? The answer lies in a hidden software framework discovered alongside that leaked video, labeled Accessory Sensor Manager. This code outlines exactly how these in-development earbuds are supposed to work. Let's look at the actual specs the code reveals. This diagram shows a standard 4K smartphone photo alongside the AirPod output. When you actively ask the earbuds to look at something, they compress the view into a tiny 640 by 640 pixel square. If they are just passively scanning the background, the resolution drops down to a highly pixelated 320 by 320 grid. And if you want to capture a quick clip, you can't. The framework shows absolutely zero support for standard video recording. Even the low-res stills it does capture are walled off. The software architecture explicitly prevents these images from ever be saved to your normal Apple Photos library. If you judge this as a wearable camera, it is an abysmal piece of technology. The specs are objectively terrible for taking pictures. That means taking pictures isn't the point at all. A traditional camera is designed to preserve a beautiful image for humans to look at later. This system is designed to extract raw data for a machine to process right now. Those pixelated, low-resolution squares aren't meant for a photo album. They are lightweight data feeds built to feed Apple's visual intelligence system as fast as possible. The AI takes that crude visual data, parses the shapes and text, and extracts immediate context. It reads the restaurant's name, translates a foreign menu, or identifies a passing dog. In those moments, you don't actually need a pristine, high dynamic range photograph of a restaurant. You just want to know if it requires a reservation. Apple is giving their AI a set of eyes, creating a perception layer that interprets the world instead of just recording it. Because of where earbuds sit, two independent sensors mount perfectly on opposite sides of the skull. The leaked framework takes heavy advantage of this placement. The code reveals specific parameters for dual camera calibration and real-time head motion compensation. Synchronizing visual feeds from both ears creates overlapping vision cones, allowing the AI to triangulate exact depths and map objects in space. When you turn your head, the AI calculates the new angle, maintaining its spatial lock. This architecture turns a pair of headphones into a sensing node that tracks the world relative to the user's body. The architecture divides this sensory input into two distinct states of operation, active and passive. Active mode kicks in when explicitly requested. You use a wake word to ask Siri, "What book is this?" and the earbuds snap the 640-pixel image to analyze the cover. Passive mode uses that extremely low 320-pixel resolution. At that size, cameras perform continuous, low-power scanning, quietly monitoring your environment without draining the battery. We are used to a strictly reactive computing loop. You ask a question, the computer answers. Passive scanning flips that into a proactive loop. The computer observes your surroundings and determines on its own if something is relevant to you. That continuous, quiet observation is the foundational requirement for true ambient intelligence. If an AI can understand the world around you, it needs a way to talk back. And this is where display-based wearables run into massive physical constraints. To project a digital map into your line of sight, smart glasses require complex internal optics, heavy batteries to power the screens, and an entirely new augmented reality interface that you have to learn to navigate. Then there is the massive friction of prescription lenses. A tech company building smart glasses has to account for changing vision prescriptions, varying lens thicknesses, and users who need bifocals or astigmatism corrections. Apple's apparent workaround bypasses all of this. They mount the perception hardware right beside your eyes and deliver the interface entirely through your ears. The optical problem disappears. You can wear your cheap reading glasses, your designer frames, or your daily contacts. The computer operates completely independently of your vision correction. Apple is treating the display as a choice rather than a requirement, shifting the interface from the visual field to the ear. Of course, wearing outward-facing cameras in public introduces serious social and privacy hazards. The leaked software framework contains strict controls for hardware status indicator lights and outlines a reliance on on-device peripheral inference. That ensures the visual data is processed locally rather than constantly uploaded to a remote server. If this product is going to survive the public square, the design has to clearly separate the concept of an AI perception device from a secret recording device. By the time a mature version of this hardware ships, potentially around 2027, it will act as a selective filter for your own attention. It watches the periphery, tracking a hazard on the sidewalk or spotting the exact blue awning of the restaurant you're looking for. And crucially, it knows when to keep quiet. A good ambient AI doesn't narrate every red car and fire hydrant it sees. It only interrupts your thoughts when the world contains something actually worth knowing. The killer wearable of the next decade probably won't put a glowing computer screen in your field of vision. It will quietly give the computer its own view of the world and just whisper the parts that matter.